Hello everyone, my name is Anisha Soundare. I'm going to talk about probability and sampling under advanced educational research methodology and statistics. So introduction to probability and sampling. Probability sampling is a fundamental concept in statistics and research methodology. It refers to the process of selecting a sample from a population in such a way that every individual in the population has a known non-zero probability of being selected. This ensures that the sample is representative of the larger population, allowing researchers to make accurate inferences and generalizations about the population based on the sample data. Probability sampling techniques are crucial in a wide range of fields, including social sciences, market researches, public health, and many others. By employing these methods, researchers can obtain unbiased and reliable data that accurately reflects the characteristics and behaviors of the targeted group. This, in turn, enables them to draw meaningful conclusions and make informed decisions that have real-world implications. Now we are going to see about the types of sampling. Number one, simple random sampling with example. Simple random sampling is a fundamental technique in a probability sampling where each item in the population has an equal chance of being selected. This method ensures that the sample is representative of the overall population as the selection is purely random and unbiased. An example of simple random selection would be researchers studying the average height of a student in a university. They could assign a unique number to each student, then use a random number generator to select a sample of students to measure. This ensures that every student has an equal probability of being included in the study, and the result can be generalized to the entire student population. The key advantage of a simple random sampling is its simplicity and the ability to make statistical inferences about the population bias based on the sample. However, it may not be the most efficient method for certain types of populations, such as those that are geographically dispersed or have other characteristics that make a random selection difficult. Now, systematic sampling with example. Systematic sampling is a probability sampling technique where the selection of the sample element from the population is done at regular intervals. This method involves choosing every nth element from the population, where n is determined by dividing the total population size by the desired sample size. The first element is selected randomly, and then the remaining elements are chosen at fixed intervals. For example, in a town with a population of 10,000 people, if you want to select a sample of 500 individuals, you would divide 10,000 by 500 to get an interval of 20. You would then randomly select the first participant and then choose every 20th person after that until you have the sample of 500. This systematic approach ensures that the sample is distributed evenly across the entire population, providing a more representative sample than a simple random sampling. Now, stratified sampling with example. Stratified sampling is a powerful probability sampling technique that involves dividing the targeted population into distinct subgroups or strata based on the relevant characteristics such as age, income, location, or industry. By ensuring that each stratum of adequate representation in the sample, stratified sampling helps to increase the precision and representativeness of the data collected, leading to more reliable and accurate insight. An example for stratified sampling could be a market research study or consumer preference for a new product. The target population might be divided into strata based on factors like age, gender, or income level. The researcher would then draw a random sample for each stratum, ensuring that a final sample reflects the proportions of these characteristics in the overall population. This approach helps to capture the notions and variations within the targeted market, providing a more comprehensive understanding of the consumer behavior. Now, cluster sampling with example. Cluster sampling is a probability sampling technique where the entire population is divided into groups or clusters and the random sample of these clusters are selected. Unlike sample random sampling where individual units are randomly selected, clusters sampling involves randomly selecting entire groups and clusters and then collecting data from all the members within the selected clusters. An example for cluster sampling could be the study of cluster buying habits in a large city. Instead of randomly selecting the individual households across the entire city, the city could be divided into clusters based on the neighborhoods or districts. The random sampling of these clusters is then selected and data is collected from all the households within the chosen neighborhoods. This method is often more efficient and cost effective, especially when the population is spread out over the large geographical area. Now, multiple stage sampling with example. Multiple sampling is a complex probability sampling technique that involves multiple stages of sampling. This method is particularly used when the targeted population is geographically dispersed or difficult to assess as a whole. In multi-stage sampling, the researcher first identifies larger clusters or primary sampling units such as states or countries and then randomly selects the subset of those clusters within each selected clusters, and researchers then identifies smaller secondary sampling units such as neighborhoods or schools or randomly selected subsets of those. This process can be repeated for additional stages until the desired sample size is achieved. For example, in the study of student achievement, a researcher might first randomly select a few states and then randomly select a few schools district within each state, and finally randomly selecting the few classes within each district. By using this multiple stage approach, the researcher can effectively gather data from the representative sample of overall student population without having to travel to the survey every single school or a student. Advantages of probability sampling. Unbiased representations. Probability sampling ensures that every element in the population has an equal chance of being selected, resulting in an unbiased representation of the targeted population. This allows the accurate inference on generalizations to be made about the entire population. Number 2, statistical validity. Probability sampling techniques such as random sampling provide a sound statistical foundations for data analysis. This allows researchers to make reliable statistical inferences, calculate margins of error and determine the level of confidence in their findings. Reduce sampling bias. By using the random selection method, probability sampling minimizes the potential for selection bias, which can arise when certain individuals or groups are more likely to be included in the sample. This helps ensure the validity and the generalization of the study results. Flexibility and adaptability. Probability sampling offers a range of techniques including simple random sampling, systematic sampling, stratified sampling and cluster sampling, which can be tailored to meet the specific need and constraints of different research content. Replicability and comparability. The standardized procedure and probability based selection inherent in probability sampling allow for the replications of studies and comparisons of findings across different research settings, enhancing the overall credibility and reliability of the research. Conclusion. In conclusion, probability sampling is a powerful tool for conducting robust and representative research. The various types of probability sampling, including simple random sampling, systematic sampling, stratified sampling, cluster sampling, and multi-stage sampling, each offer unique advantages and can be tailored to different research objectives and concepts. By understanding the strengths and limitations of each method, researchers can select the most appropriate approach to ensure their findings and statistically valid and generalization. Thank you.